Hello everybody, Chris here, and in this video I want to show you how you can use the Tileset tools in order to build a game level inside of Unity. So right now for the start of this tutorial, I have a platformer character with the most simple of controls, can walk left and right and jump. That's about it. I've already set up a component where the character can be a targetable object which can take damage, and we'll use that later to set up some spikes that can damage the player. And then with that spikes game object, we'll be able to paint that object onto the scene using the Tileset tools. So if you create your project using the standard 2D package, you'll be able to right click, go to 2D object, and then Tileset. In this case, we're doing a left-right platformer, so we're going to want rectangular squares for our tiles. So let's go ahead and disable the test square game object. We don't need that anymore. And let's open up the tile palette window so that we can create the tiles which we'll use to actually draw onto the grid here. So let's go to window and then 2D tile palette. I like to position it in the top right next to the inspector. So here you can see we have a blank window for where we select the tiles to draw. We have the create new palette option, and we have the tools we can select, such as the brush tool or the box fill tool or the bucket fill tool. So I'm going to start by going into the art assets here, and then I'll drill down to pixel adventure, terrain, and then I'll create a folder here for tile palettes. So I'll right click, create folder, palettes, and then let's create a new palette. So I'll click create new palette, and let's just call this terrain pixel adventure. For grid, cell size, and sort mode, I'll just leave it as the defaults for right now. We'll hit create, and then I'll find the folder and go into palettes, select folder, and if we open up the palettes, we should be able to see that palette file there. So next we're going to need to create a whole bunch of tiles based off of the PNG image here. So I want another folder just specifically for the tiles associated with this palette. So I'm going to select the palette, F2 to select its name, Control C, and let's create a new folder with the same name. So it's going to be palette / terrain pixel adventure. I'll rename it at the start, and let's add in tiles _. So it's tiles terrain pixel adventure. It should be clear enough. Now let's go back out to the terrain folder here, and I'm going to select this image. We got to set it up in the inspector so that it's split based on the tile size for each of these tiles in this file. So I'm going to make sure sprite mode is set to multiple here. Let's go to the sprite editor. I'm going to click on slice and then type, and we can do grid by cell size, which is going to allow us to split this image up based on a cell size, a number of pixels, horizontal and vertical for X and Y respectively. So I know that it's 16 by 16 for this sprite sheet. So as you can see, each of the tiles are now going to be sliced up perfectly as soon as I hit apply. And then let's hit apply one more time. Okay. And now if I was to click on the little expand arrow here for the image, you can see all of the image files. Now they're not actually a tile asset yet. We need to go back to the tile palette in the top right hand corner. And I'm just going to drag this whole thing in, kind of like so. If you want, you can zoom out with middle mouse wheel scroll so that you can see exactly where you're putting it. I'm going to put this entire image onto here. Let's go into palettes, tiles, terrain, pixel adventure, select folder, and it's going to generate the tiles into this folder. So there's going to be one tile for every 16 by 16 square that actually had visual information. So let's select it, and you can see all of the tile assets being generated here. And it may take a second. Okay, but once that's done, you should see them pop up here on the right. And you can also confirm it by going into the folder and checking the tile assets. You can click on them and see this is a .asset file, which is a little different than what you will see if you go back out to the image and you click here. Okay, anyway, now that we have the tiles located over here in the tile palette and we have a grid, we can select the grid and then we select the tiles we want to draw. Let's try this wood tile over here. And then you can start painting with it. So select the brush tool and then go to the grid, left click, hold, and drag. And that is adding some tiles to the scene. Now, if your tiles don't fit the 1x1 grid here, then that's probably because on the terrain that you are selecting, your pixels per unit don't match the size of the tiles. So I made the pixels per unit on my sprite importer 16 because I know that the tiles in my game are 16 by 16. So it makes sense for them to take up 1 unit, just making it really easy to understand that 1 unit in the game is 16 pixels across and 16 pixels tall. So if we click up here, we can see I have a pixel texture importer. And that's what's being applied as the defaults for anything I import into the game. That was in my last tutorial if you want to know how to do that, where if you import a file, it will use these as default settings. Okay, so putting that aside, we can kind of start drawing our game level. So let's just draw something simple here. So you just select the tiles and then you left click on the grid and you just kind of go around until you have something you like. A good tile set will make it really easy to understand what connects with what. So you can see right here, this right wood edge is going to connect with this top right corner. And then everything in between here can be filled with this middle thing. So I might go to the bucket fill tool over here on the right and just select there, left click, and now it's filled. Okay, and we can draw more sections if we want. So if we wanted to have a block with this kind of style, then we can go over here. Let's create the left edge first, and I'll just drag that down, create a bottom square, go to the right, and then up. You can, of course, do other shapes rather than just, a rectangle. So if we go over here, then we can just keep following the edge line and trying to make it look correct. So let's take this bit over here and draw it to there. And now at this section where it looks a little funny, we just need to find the tiles that actually match here. So I think that, in this case, I think maybe this tile over here is what was intended to kind of hang off the edge a little bit there. Not certain on it, but based on your tile set, you can kind of try and figure out what works for you. Let's also try the box fill tool here. So you select the tool, you left click, you drag a box, and anything inside is going to get filled. So if I want, I can click over here, top left corner, drag a box, go to the bottom right hand corner, and fill it in with those tiles. Okay, let's also put a little platform that goes between these two. So I'll just draw that in there. Okay, so now we kind of have a level that our player would be able to theoretically walk around and jump across and do platformer stuff. But as things are right now, the tilemap is going to let the player fall through the ground because the tilemap doesn't have a tilemap collider. So I can demonstrate that right now. We'll just go ahead and hit play here. So let's go ahead and hit play here, and we'll see that the player just falls straight through the ground. So what you want to do is take the tile map as the game object, go to add component, add a tilemap collider, and then this will add a square collider basically to every single one of these tiles. Now, as things are right now, these are separate colliders. So sometimes, depending on how you set up your player controller, they may get stuck on the edges between these individual tile colliders. So we'll hit play and we'll see if that actually happens for us. So let's hit play and I'll walk. And for this character, it's working just fine. Probably because the velocity is being set. And for this mask dude character, it seems like it's working fine. His movement is basically being set by directly setting the velocity, not adding forces on the character. I think I've noticed that that usually happens when you're using add forces. But in any case, if you want to combine all of these colliders so you never get stuck on the edges, what you can do is add another component to your tile map. And that is going to be of a collider type. Let's see, composite collider. So we do a composite collider 2D, which is going to add a rigid body component. And since this is a tilemap grid, we don't want physics or anything on it. So let's change the body type to static, which just means it's going to stay in one place. And then for a tilemap collider, you check used by composite. And when we do that, you'll notice that all of those individual grid lines of the tile map go away. So there should be nothing left to get stuck on as we go from one tile to the other tiles. And just to make sure that it still works, let's go ahead and hit play. If your body type is static, you shouldn't see the ground fall or anything like that, and you should still be able to walk across it, as you would expect. Now, one tiny thing, if we look at the character, we might see that he's standing just above the ground. So that is going to be a easy fix. We just got to go into the prefab of the player mask dude, and let's take a look at the collider. So the capsule collider, let's edit the shape and just bring this bottom side up a little bit. Then we can hit play again and just make sure that the character is standing on the ground there. Now, if I look really closely at it, it might actually be fine as it is right now. The problem might actually be more like the background. So let's add in a background so that we can easily see how... now let's add in a background so that we can easily contrast it with this dark tile set, rather than having just the main camera with this black background. It makes it a little hard to see what's going on. Of course, you could also change the color of that camo if you want, but flat color is kind of ugly. So with these individual PNGs, there are a few ways you can create the background. One would just be to create a game object. Actually, I'll do right-click 2D object sprites square. This is going to have a sprite renderer, so we can drag one of these images onto the sprite area, but it hasn't been imported properly. So these are currently importing as sprite mode multiple. So I'm going to select them all and change it to single, hit apply, and now we should be able to use them as the sprite renderer here. So let's just try a blue background. Okay, and we can do draw mode tiled. So we get a message here saying that we need it to be set as full rect mode on these assets. So if we select them all and change the mesh type here to full rect and hit apply, then that should go away here as a problem. And if we do the draw mode width and height, set that to 50 or something, and maybe we need to change the scale down to 1 by 1, then now we have a background. So we can hit play and test how it looks with that background. So looking a lot better, and we can definitely see that the black edge of the character's pixel is sitting right on top of the ground here, which is what we want. Now, another way of doing basically the same thing would be to use the tile maps and then just draw using the box fill tool to add a background. So I can delete this square here, the game object. I'll go to the grid. Let's right click, create a 2D object, tile map, rectangular. Now here we have two options. We can add these files to the existing tile palette, but if that doesn't make sense to you, we can select from the palettes dropdown, create a new palette, and let's say background. We could just leave it as that, just background. And I'll save it in the backgrounds folder with right click new folder palettes, select folder. Okay. So if we double click into it, we have the palette file here. Let's add a tiles. So I'll call it tiles underscore background. Okay, let's go back out, select all of these PNG files, and just drag them into the tile palette. And let's make sure that these tiles go in the right folder. So art, pixel adventure, backgrounds, palettes, tiles, background, select folder, and we have them. Okay, so now on this new tile map, which I will rename background, and the first one can be, I guess, foreground. We'll take the background grid, select the background we want. But if we try to draw with these, we can see that these aren't actually matching the grid scale of the rest of the game. So a quick fix for that would be to take the size of the image, 64 by 64, and make that the pixels per unit. I think that should work. So I'll select all of these, 64 pixels per unit, apply, and let's go to tile palette and start drawing the tiles. So yep, this seems to be working just fine. So let's use the box fill tool and just select and drag across. Now it's scaled to the grid size correctly, but we have another problem, which is that it's showing in front of everything else. So the quickest fix might be just to move this up in the list. So what we want to do is set the ordering for the items to draw on the screen. So take the background game object for the tile set, go to inspector, and then we want to take the tile map renderer, order and layer, and we can change that to something like -1. So that means it's going to show behind anything that has a number of 0 or greater here. Another way is you can add custom sorting layers with their own ordering. So something in this new layer 1, if I drag it up to the top, would always show behind default. And if I move new layer 1 below, then anything that's set to the new layer 1 would show above the default layer. I'm going to remove that for right now, and I'll just keep it simple using order and layer and numbers here. So the foreground has a 0 here. The player is also going to be on the default layer with the order and layer of 0. So that should be fine because the player is always going to stand on top of this foreground. It should never really be going underneath. If we want, we could just make sure that it always shows in front by going into the prefab and changing the order and layer to 1. Then it will always show on top no matter what. Maybe that would be better. You can always kind of test around and see if it reacts how you like. And that's pretty much it for our background. So like we can go to the tile palette and just make this way bigger. Just make sure that anywhere that your character can be in the game, that there's always going to be a background and you don't just get some mysterious gray empty space from just the camera. Okay, let's hit play and give things a quick test. So we can walk around, I can jump over there. I can also fall down to this platform down below. If I go over to the left side and kind of walk off the edge, you can see that it kind of lets the character slide off because it's got that circular curve on the bottom right. So if you want it to either be completely on or completely off the platform, then you might want to change the capsule collider to a box collider. That way there won't be like that slippiness on the edges. But up to you. And now let's come to the part where we actually draw game objects using our tile palette. So let's create a spikes trap that can damage the player. So I am going to go to the traps inside of the Pixel Adventure art pack, go to spikes, and let's just bring this asset onto the scene. And let's just bring a copy of the idle image. Okay, and let's select this image. So for the asset here to be able to be used in our scene, we either need to slice up the multiple sprite mode or change it to single. In this case, single would work. We can also do multiple still, and then just go into the sprite editor, do slice, grid by cell slice, and that's 16 by 16, so we get one slice, hit apply, and that actually gives us pretty much the same thing. So we can drag idle 0 into the scene. Let's double click on that, and I'll hit W to go to the movement tools, and we can just drag it over here to the right. So we have our spikes in the scene. So let's create it as a prefab. So in the assets folder, I'm going to right click, create folder, and I'll just call this traps here. I'm going to rename the game object idle 0 to spike trap. Let's open up the traps folder in the project. I'm going to drag spike trap down here. Okay, so we have our prefab. Let's click on spike trap, and I'm going to jump into the prefab. So our spike trap currently doesn't do anything, and it can't collide with the player. So what we want to be able to do is make it so that when the player walks into the spikes, that it is going to take damage. So I will have to add a couple components here. So let's add a component box collider, and we can see that this is 1 unit by 1 unit right now. So I actually do want to take these spikes and put them down here. So the player could technically walk across this region, but the spikes will damage it. So I'm going to take the scale Y of the spikes and just double that. And then we'll take the size Y of the box collider, make that 0.5 to scale it back down. Okay, so for this trap, let's go ahead and offset the box collider by -0.25 and just make it come down here. Okay, and then we need a rigid body. So I'm going to add a rigid body 2D component to it. We're going to make it static because we don't want this to move ever. We only want the player to be able to collide into it. And let's kind of shrink those a bit. Let's go back out and let's test by hitting play and seeing if the player can actually collide with this object here. So I'll walk into it and you can see that we can stand on it and we can walk into it, which is kind of what we're looking for our spikes. Now, for the spikes to deal damage to the player, we need to create a tiny script for it, and we'll use this targetable object component in order to deal damage to the player. The targetable object, when the health reaches 0, will destroy the player. So just to take a quick look at this tiny targetable object component, we have the health as a field, and we have health as a property. So when we set the health property, we update the field value, and we check if the field value reaches below or equal to 0, and then we destroy the game object if that happens. And then we also have a take damage method. So when we pass in the amount of damage we want this targetable object to take, we subtract that amount from the property, and we can also update the animator to play a hit animation as a trigger. So that's why the animator is there right now. Okay. So let's add our new script for the spike trap. I'm going to add a component. I'll call it damage on collision. New script, create an add. Let's edit the script. And we're going to need up here at the top a field for how much damage we want the player to take whenever it collides with the spikes. So I'm going to do as a attribute field : serialize field. So this is going to create a automatic backing field for the property. and then it's going to serialize it to the inspector so that you can actually set the value. So let's go ahead and do a public int, and it's going to be damage, get, and then private set. Okay, so what this means is that we have a automatic field generated. The field is serialized. The property is public so that we can access it from other scripts if we want. And then the property type is an integer value. We can get the value as a public getter, and we can set the value only as a private setter, which means you can only change this property within this script, or you can update the field value in the inspector. So that just means that other scripts can't mess with the damage value of this damage on collision component. So putting aside the fanciness, let's do the on collision enter 2D. So I just type that in there, and Visual Studio can autofill it, but it's a private void on collision enter 2D, and it takes a collision 2D collision as a parameter. So let's get the targetable object component from the collision. So targetable object equals collision.GameObject.get component, and we're going to be looking for the targetable object script. So if targetable object is not null, then we'll make it take damage. So this is already like a pre-check to make sure that whatever collides with this damage on collision object is a targetable object. So it won't just damage anything random. It has to be a targetable object which has the health property in order to actually deal damage to it. So we'll do targetable object dot take damage and pass in the damage property. And that is pretty much all we need for this little script. I'll show the player controller in a minute at the end of this video. So let's go back out here and I'll hit play. So if we go back out to Unity, we can see the field, the automatic backing field here is set to the default value of 0. We might want to give it a value. So you can still set the default value on that field by adding a equals 5 or whatever you want to the end of this line here. So if we go back out, you'll see that doesn't automatically update here because it's already been serialized. So we got to set the value manually. But if we were to add a new damage on collision component like that, you can see that new default value will show up there. Okay, so now we can hit play and see if we can make the player die. So let's hit play, run into it. Okay, we can see the hit animation actually plays there. Now it's looping, which isn't what we want. I'll fix that in a minute. But we can also walk into it again, and you can see that that makes the player's health go to 0, and the player is deleted from the scene. So let's quickly check out the animator here that I have set up. So if we go to the hit animation and check its out transition, we can see that it needs a exit time to be valid. So that's my bad. I should have set exit time to 1 in order to make it so that the hit animation plays, and then we automatically transition out of there. As it is without having a has exit time, it'll never leave the hit state. So that's what was going on with the animator there. So let's go ahead and hit play, and I'll run into it. Okay, we could kind of see the hit animation play there. And if we run into it again, our character dies. Okay, so we have a way to damage the player here. That's not the main point of this part of the tutorial. The point is to make it so that we draw on the tile map and set up these traps to be there automatically and also tied to the grid. So let's finish by going in here a little bit. I want to edit the box collider shape just a tad. And I'm going to pull the top down to the top pixel here, just because I think that makes more sense. And now let's go to the tile palette for Terrain Pixel Adventure. Okay, so now if we want to start drawing with these spike traps, what we need to do is to go into the tile palette. And you don't actually need to drag the images in here as a brush that you're going to draw from this palette, but you can actually just go to default brush and change that to game object brush. And just to show you don't have to have anything selected, let's select something random, and you just expand element 0 and set the game object here. So I'll just drag spike trap into the game object and draw it where I want it on the scene. You'll notice though, with game object brush selected, you can select other options for the active tile map. You can paint on the scene root if you want it to be at the root of the hierarchy, and also the background and foreground tile maps or under the grid itself. So if you need the hierarchy for where these game objects show up to be different for any reason, you can do that. So let's just go ahead and use this game object brush and draw on the game object. So anywhere you want the spikes, just left click and put them in. Now you see a limitation of the prefab we had set up, and I didn't actually know about this prior to the tutorial, but the scale that we had set on the prefab gets reset for these individually created objects. So you can see that their scale is set to 1 automatically. So if you really needed to stretch a sprite, it might be better to edit the pixel art and then change the scale back to 1 just so they show up properly when you're creating them like this. But they do work just like the other spike traps. And as a temporary workaround fix, we could select these 2 spike traps and just double the Y height, change the position to -1, and they're in the place as we need them to be. We could also just use the tile palette, select the spike trap, and draw in some tiny spikes if we want that as well. And we can test the spikes to make sure they all work the same as intended by going into play mode and testing them out. Now, when I walk on the spikes, you'll notice that I do take damage on the first spike, but I don't die. Even if I stand here, the damage is only being applied on collision enter. So that's the first time the player steps on to the spike until it has left the collision. It won't apply the damage again. But if I walk further onto the second spike, you'll see that it dies because that is a new collision with the secondary spike. And I can reset the scene and we can jump across and show that these tiny spikes still work and deal damage as before, but their sprite and the box collider is half the height. Maybe you want 2 versions of the spike, one that's tall, one that's short, so you could do it like that. But what's really handy about drawing the game objects is that they are going to always match the grid when you draw it in this way, because you are drawing tiles on a 1 grid square by 1 grid square. So it makes it really easy to get a pixel perfect snap for your game level. The last thing I wanted to show was just this simple player controller script that I'm using for the video. So there are much better player controllers out there, and I have other ones on my channel if you need a better platformer controller. But just for the simple demo, we have a walk speed property and a jump velocity property. This is just how fast it can walk, how high it can jump, what we set the velocity to when it jumps, and then this will be decreased by gravity over time until the player hits the ground. We get access to rigid body animator and sprite renderer as our necessary components. And using the standard Unity input system, get the horizontal axis for the X input. We have the defaults for the XY velocity that if we don't change it, then that's what it's going to be set to for the velocity. So if the X input isn't 0, then we are moving horizontally. So we set the X velocity to the walk speed times the X input for the direction. And depending on if that's positive for right or negative for left, we can flip the sprite renderer. So we get left-right movement without needing to create separate animations. Set the animator property is moving in the animator, so controlling whether it's showing the idle animation or the run animation. And then for the jump, if the get button down jump is pressed, which in this case is spacebar, then the Y velocity will be set to jump velocity. The rest of the velocity is just controlled by the dynamic rigid body's gravity setting. So aside from that, we just set the velocity on each frame, X velocity, Y velocity, calculated based on this input. And then the gravity is automatically calculated by the Unity physics engine. And that's really all there is to this simple player controller. So I'm just going to add a couple spikes in here for good measure so I can get a screenshot of this for the thumbnail. But aside from that, that is pretty much the basics of creating a tilemap level inside of the Unity game engine, including how you can paint game objects directly onto the level grid. So that's going to be it for this tutorial. If you're interested in downloading the scene, the assets, and all of the scripts for this tutorial, I'm going to have them up on Patreon. But aside from that, thanks for watching to the end, and I will see all of you in my future Unity content.